Welcome back. In our last lesson, we learned how to find the center of a dataset using mean, median, and mode. But that's only half the story. Today, we learn how to measure the spread or dispersion of our data using variance and standard deviation. Why do we need to measure spread? Because the center doesn't tell you everything. Imagine two cities that both have the exact same average temperature of 15 degrees Celsius. In one city, the temperature is stable all year round. In the other, the summers are scorching hot and the winters are freezing cold. The average is the same, but the experience of living there is completely different. Measures of spread tell us about these wild swings. Our first tool for this is variance. Variance is a powerful statistical measure. It calculates the average of the squared distances of every data point from the mean. So, if a data point is far from the mean, it adds a lot to the variance. A big variance means the data is very spread out. The only tricky part is that its units are squared, like dollars squared, which can be hard to interpret. This is where our hero, the standard deviation, comes in. The standard deviation is simply the square root of the variance. And by taking the square root, we solve the unit problem. The standard deviation is back in the same units as our original data. It gives us an intuitive number that represents the typical distance any given data point is from the mean. This gives us a very quick way to understand our data. A low standard deviation means the data points all clustered tightly together around the mean. The data is very consistent. This is like the heights of adult men. A high standard deviation means the data points are spread out over a very wide range. The data is inconsistent, like prices on the stock market. Understanding spread is absolutely critical in AI. It's the primary way we perform anomaly detection. Any data point that is, say, 3 standard deviations away from the mean is very unusual. We also use it to scale our features before feeding them into a model, ensuring no single feature has a disproportionately large range. And it helps us evaluate our models by understanding the consistency of their predictions. So now we have a much more complete toolkit. With measures of central tendency, we can find the typical value. And with measures of dispersion, we know how consistent that value is. Together, they give us a powerful, 2-number summary of our data. In our next lesson, we'll put all this together to understand the overall shape of our data by exploring probability distributions.